previous class, we have discussed whatever the transactions, how could you write the transactions? What are the asset properties? How could you write the transaction? And how could you apply read item, write item, how these can be get separated? Then these things were discussed in the previous class. Today, I'd like to concentrate what kind of problems will be faced when interleaving kind of transactions will be gets executed by database management system. So how the interleaving processes will be, transactions will be, and what are the different kinds of problems which are existed when interleaving kind of execution could be happens with the database management system transactions. Let us have a look here. So before going to, already this has been seen in the previous class. Even I'd like to discuss this one more time. This is entire T1 transaction. T1 has been followed after execution of this particular T1. So then T2 will be gets followed here. Then T2 will be gets followed. So this schedule will be called as transaction. First transaction, entire transaction will be followed. So second entire transaction here. So this is the schedule. T1 followed by T2. T2. People will be call it as T1 followed by T2, followed by T3, followed by T4, and so on. Whatever the combinations that might be. And second thing will be in reverse way. First T2 will be completed, then followed by T1. T2 will be gets completed, then followed by T1. So it could be considered as a T2 followed by T1 here. It is in reverse order. Okay, in reverse order. So probably you have some kind of schedules. Otherwise, CPU scheduling algorithms in our operating system says that how the systems, processes are going to be executed when operating system is concerned. In the similar way, here also the transactions. And next one is interleaving kind of thing. Interleaving in the sense, so two instructions of T1 is being executed, then followed by T2. T2 of two instructions, followed by T1 two instructions, and so on and so forth. Okay, in this way, this is one kind of interleaving, and this is another kind of interleaving. Another kind of interleaving here. So we are supposed to concentrate on this kind of activity here. We are supposed to concentrate this kind of activity, and we also identify what are the problems when like this kind of interleaving kind of execution could be gets happen by the transactions in databases. So we are trying to concentrate this one. Afterwards, we shall implement some locking mechanism also afterwards. Let us go ahead. First problem, whichever available or existed in database management system, if interleaving kind of execution could be happen. If interleaving kind of execution of many number of transactions are going to be executed, then the first problem which could be gets occurred will be called as the dirty read problem. The dirty read problem. Otherwise, this problem could also be called as the lost update problem. Any one of these are same. The dirty read or lost update problem. The same thing in terms of operating systems. The same thing will be called as like this. The same thing will be called as the race condition. Race condition. Okay. Race condition is of course, operations will be took place in either database management systems or operating systems will be same. Everything is same, but the naming convention is somewhat different. So this whatever I have selected here, it's been happen in operating systems, whereas this one, the lost update problem, otherwise dirty read problem will be called as database management systems problem. So to explain this particular problem, let us consider the scenario, how the scenario could be when this particular system will be, this particular kind of of scenario will be existed in two different types of systems or transactions. Let us examine. So look at this. Two transactions T1 and T2 are updating. So most probably many number of transactions are programs which are intended to written by any software engineer in real time will be done only one operation, that is updation. Okay, very few situations you could also operate insertion. Insert could also be operated by you. The most probable operation will be, or most the generous operation will be updating. So updating the same data element, you try to understand, this is very important. Same data element, then the updations will be overwritten. Since it is overwritten, whichever has been updated first, that updation will be lost. Okay, so which update will be, which transaction will be done, that update will be gets lost. For doing some kind of, for explaining this kind of situation, I'd like to consider these considerations. Let us see. So first consideration is, let us consider this is the server. So this could be the server here. So let us consider this particular point will be considered as the server here, and this particular server is being connected by many number of clients. Out of those, there is one particular client, the client one here. This client one is being running one transaction. That transaction is being considered as a T1. The transaction is a T1, which is being running by the first client, and another client also be there. So this particular client also be running. So one more transaction. This client name is client 2, and he is running with transaction 2. And as far as the server is concerned, server has agreed. The server has agreed the interleaving execution of these two transactions of client 1 and client 2. Server has agreed that yes, interleaving execution of transaction 1 and transaction 2, which are being run at client 1 and client 2 geographically. They are not just this sites, they will be geographically somewhere else. Now, those two different types of transactions have been sharing only one database. So let me say that the database does have two different types of elements. First element is X and the second element is Y here. So let us consider this is so X and this is Y here. Two different types of database elements, and the database which is contained these X and Y are same. Okay. Now, so within this particular regard, let me consider for explanation point of view, let me take it as here it is 10 and here it is 20, for example. Okay, now, so transaction T1 has been initiated at delta T1 time, delta T2, so T3, T4, so this is T4, here it is 5, 6, 7, 8 and 9. So totally 9 units of time is required to finish up this particular process. So at delta T1 time, so transaction T1 has been initiated, it has been read the data. What actually the read will be? It must be referred to the server where exactly the data will be. So it has been taken into consideration. An entire block is being copied. Entire block is being copied from hard disk to so the random access memory of your local machine. The random access memory of your local machine. For example, this X value has been copied to your local machine. So that is value is X having 10. After that, in your client machine, there is a variable. That variable is called as X. Within that particular variable, yes, value has been copied from your random access memory to your program variable. Now, what we are trying to perform, X equal to X minus N. For example, N will be equal to or capital N or small n, whatever it may be, will be equal to some 5, for example, 5. For example, it could be 5. Where M will be equal to, so for example, it is 20. For our time consideration, we'd like to consider as 5 and 20 as N and M values respectively. Now, what is the next operation which could be taken? X equal to x minus n. So 10 will be over returned as 5 after operating the operation x equal to x minus n. Now interleaving could be took place. Now turn will be comes to transaction T2. Transaction T2's turn will be taken here. So there is one operation which is being done here. There is one modification on X which is being done by the transaction T1, which has not reflected in server, which is not reflected in server. In server, what is the value? So 10 as usual. So previous state value has been maintained as well. Now at this moment, the transaction T2 has been read the value. So here also for transaction T2, some random access memory could be there for that particular machine. So this is random access memory of second system. This is random access memory of first system. Okay, so here it is x. So this is the value of x here, which is having some 10, and this 10 has been copied from over there to the local machine, local variable, that is again x only has been copied. Now, what exactly done? X equal to x plus 20. So this value can be overwritten on execution of that particular expression. So let it be 30. Let it be 30. After performing these two operations, then it will be, so term will be given to transaction T1 back. Now what actually transaction T1 has been done? So this value of x, variables value x has been, modified value has been, the modified has been copied to random access memory as 5 here. And again, this random access memory value can be copied to this server. Okay, it has been copied to this server. Yes, everything is happened. And then transaction T1 has been performed one more operation with Y. Okay, so here also Y has been taken into random access memory. The value is 1, and here it is 20. Yes, things will be so taken into consideration. Of course, the Y will be, this is value of Y, and 20 has taken. Then two operations are get solved. After this, transaction T2's turn here, so the value has been re-returned. So what actually been re-returned here? This value can be copied to, so the random access memory of your system, that is 30, and this 30 will be copied to here. Here you need to understand, whatever the modification which was done by transaction T1 has been over-returned. That value is actually 5, that is over-returned. Okay, so whatever it may be, whatever the update which was done by transaction T1 has been lost. So that is why this scenario is called as a lost update problem. Otherwise, so if you are trying to specify without committing the, or without completion of this transaction T1, before completion of transaction T1, you have been taken the value of x by transaction T2. So it could be called as a dirty read or the lost update problem. In this way, the scenario could be. Okay, in this way, the scenario could be. So this is what about the dirty read problem or lost update problem. Both will be same. Now, second problem which is available with databases when the transactions are running with what do you call interleaving kind of execution here is the uncommitted data. Uncommitted data. What does it mean? When transaction T1 and T2 are executing such that concurrently such that transaction T1 has been rolled back after transaction T2 has been accessed. Okay, so try to understand this particular scenario here. So transaction T1 has been read the data of X, and it has been done some kind of operation, and it has been so written onto the server. So same scenario here also. Let me consider this is the server. X is having some particular value. X will be having some 10. So of course Y couldn't taken into consideration because Y is available with only transaction T1. So therefore the client T transaction, so T1 has been executed at the client 1. So that X has been taken here. So X has been taken, and here it is a 10. 10 will be modified with, so for example, n equal to 5. So 10 will be modified with 5, and 5 will be, also we have operated write item x. So it could be written back to this area. So obviously it has been done. It has been done. Things are okay, no problem. So whatever the X operation has been completely executed by transaction T1. So there is no problem at all. Now transaction T2 has been get started. So in the transaction T2, here also the same scenario here. So X has been read here. What is the, sorry? What is the value of X here? Value of X, which is available server is 5. Yes, it has been taken. 5 has been taken here. Of course, random access, it must be copied to random access memory, then our variable. So already we have discussed, so that I did not write any random access memory here. So 5 has been taken. Then x equal to x plus m. So there is m equal to some 10 or 20. So it could be overwritten by 25. 20 plus 5, that is 25. Before going to do this particular write operation, so turn will be goes to transaction T1. So here the value which has been modified by transaction T1 was rolled back. Rolled back in the sense x value can be, so look at this particular x value can be again seems as it is value, that value is 10 again. That value is 10 again. So previously, without modifying or without committing, transaction T2 has been read the data of X, server's data X, whereas here everything has been done properly, and because of some failures, so transaction T1 has been rolled back. Okay, because before rolling back, the data has been read by the transaction T2, so that is why it is called as uncommitted data. Uncommitted data. Okay, so because of uncommitted data, this property will be always violating the isolation property of acid properties. Okay, so this is what about the uncommitted data. Then, because of these, what kind of problems can be? Still more, any problems are there? So yes, still more. Always serializability will be serializability in the sense the transaction T1 must be followed by entire transaction of T1 must be followed by T2, or entire transaction T2 followed by T1. So this is the point which we have to consider as serializability. Entire transaction will be executed executed with server, then all different kinds of asset properties have been called. So atomicity, single unit of a transaction T1 has called. Then SC, consistency, one consistent state to another consistent state will be gets occurred. Then durability, entire transaction will be executed so properly isolated. No other transaction is being interleaved. So everything has been taken into consideration while serializability will be took place. But here also we would like to consider, so if there is a possibility when concurrent systems will be taken into consideration, then preservation of database consistency is lagging. How it could be lagging? What are the different conditions here? Let us have a look here. I'd like to introduce these four. These four are very, very important for you. These four are very, very important for you. So theoretically tomorrow, let me explain. Now would like to go ahead with the practical exposure regarding to read-write conflict, read-write conflict, write-write conflict, write-read conflict. There are four different types of conflicts are there. So read-read conflict cannot be a biggest conflict. It doesn't matter. It doesn't matter. When write operation, that is update operation will be there. So when any update operation are newly introduced data, so operations will be there. Then conflict will be gets occur. Let me show you how those conflicts will be. To acquire these conflicts, you must be get operate so one particular extra command, that is locking mechanism. how these locking mechanisms can be gets occurred. Let us have a look by taking some examples with Oracle. Okay, let me go ahead and take the examples here. Okay, consider that two different types of users have been executing. Two different types of users have been executing the same kind of database here. Let us take into consideration in such a fashion. Then we will understand what is the conflict here. Then we could understand the conflict in a proper way. Let me open one more browser here. I mean one more command prompt here. Then you could understand very easily. Yeah, here also. Yeah, let me take. Both are having AMR class only. Both the prompts are having AMR class only because two different people have been executing same kind of item here. Let me show user. So look at this AMR class here also. So show user AMR class. So let me concentrate on select everything from RATE because it is very simple to know data. Okay, describe RATE. So these are the columns. Let me introduce something. Insert into RATE values. First one is ampersand T, ampersand R. Let me introduce some rows and apply for commit here. So T will be 6, 10 percentage, 12, 11 percentage. So 18, 12 percentage. Of course, enough. Commit. Select everything from RATE. Okay, this is the data. If you come across this one and apply, so select everything from RATE. At this particular user, within this particular user, I did not perform any insertions. Even I have been operated commit here because of applying commit at this user. So the rows which will be displayed here also. Look at this. Same data will be available. Now, how the conflict will be? How the conflict will be gets occurred? So, what are the scenarios to be gets these conflicts when you are trying to discuss something about the conflicts here? First of all, read conflict. To operate the read conflict, so look at this. This is the command which we have to operate. So, log table name in share or exclusive mode. So this is the command. Look at this. So here we have been operated. The table has been locked in either it is in shared mode or exclusive mode. If you consider shared mode, if you consider the shared mode, yeah, if you consider the shared mode, what does it means? It does means that read only mode. Read only mode. Many number of people can be open the file or open the table for read only mode. There is no question at all. There is no problem at all. Whereas in exclusive mode, you are trying to update the table. Okay, write only mode. When any user or any user will be trying to operate write only mode, so nobody is allowed to even read also. If I would open my database or my table in write only mode, so nobody can access that particular table until I have to finish my exclusive mode, okay, or write only mode. If I would finish the write only mode, so then everybody can access that particular data. That's no problem at all. Okay. So if you operate any kind of lock, so how could you release the locks here in the sense? Theoretically, we would like to specify one particular word. That word is unlock. But here unlock is not there. So if you operate commit, obviously all locks are supposed to be released. all locks will be gets released. Okay. So this is the command which we have to take into consideration to operate. Let us execute. Okay. On read, let me take read-only mode here first. Read-only mode on this particular user. So lock table name is read in share mode. Share in the sense read-only mode. Yes, your table has been locked. Your table has been locked. So now the same command can be gets operated here also. Look at this, the share, because both are having same kind of user. So AMR class and here also AMR class, here also AMR class. So therefore, let me operate the same command here. So table has been locked in. So share. Then both of you can operate. So only one of the DML operations, that operation is selection. So let me operate select here. Select everything from rate. Yes, you can. Here also select everything from rate. Yes, it can. There is no problem at all. But any one of them can be, because you are in lock mode. You just lock the table. So therefore, two or more number of users, clients are accessing same kind of database or table. So therefore, everybody is in lock mode only. So if anyone is trying to operate except selection within the DML operations, then it could be put into deadlock mode. How deadlock will be get circled? Let us see. I'd like to operate here, insert into at this particular table. User insert into table name is RATE values. For example, next value is 24, comma. So that is 13%. For example, if I would operate this one, this user will be put into. Look at this. This user has been. There is no SQL prompt. If there is no logging mechanism with other users, it will be immediately responded that one row inserted and SQL prompt. But here you could not get anything. Okay. So after some time, you could also see the status of this particular system in not responding mode. You can see here you can operate. Here you can operate, select everything. There is no problem at all because you have locked with read-only mode. But so both are at read-only mode. But one of the users has been operated insert operation. So write operation has been took place. So therefore, that person will be put into deadlock mode. You never operate another operation here. But the second person, he was not operated any write operation, so that it could be okay. And when he will be comes out from the deadlock mode. So when this particular person will be comes out from the deadlock mode, in the sense, there are two possibilities. First one, the opponent person, the opposite person, this particular person will be releases the lock. That is the first operation. So number one is, so when the read conflict will be there. Read and read conflict will be resolved when two possibilities are to resolve this one. First one is the second person, the person who is not yet operated any write operations, that particular person, opponent user must so unlock the share mode lock, share lock. This is one particular thing. Second thing is or either of these two, not both, either of these two, or so opponent could also apply so write operations. So how many kinds of write operations are there with us? One is insertion. While insert will be gets happen, write will be took place. Update also be write will be took place. Delete also will be taken write operation. Either of these three operations, any one of these operations will be operated by second person, then here the lock will be released. Otherwise, deadlock cannot be released here. So let me operate this one here. Commit in the sense, obviously the locks, every lock will be gets released here. So look at this, commit. Now you can see here. You can see one row has been created successfully. After the second person will be gets operated commit, then the deadlock will be gets released. Okay. Then here also apply commit here one more time. So no lock is being there at the two users. Then let me take one more time. Let me take the lock operation. Here also one more time. Let me take the lock operation. Yes, both has been taken the locks. Both has been taken the locks. Now this person is trying to insert into rate values. Next value could be, for example, 30 followed by 15 or 14, however, whatever. Okay, 14. He will be put into deadlock mode here. Okay, you can press any number of enter keys, there is no use here. Now he's also performed the same operation again, back to same operation again. So some 36 comma 15 will be taken. Look at this. This particular thing will be released, but a row cannot be included. If you operate commit, one row has been included, but here you can see deadlock is detected while waiting for the resource. Hope that you do understand. Deadlock will be detected while waiting for a resource here. So when read lock will be there, when read lock will be there, at that moment, if any write operation will be done, so deadlock will be detected. Deadlock will be detected, and this particular user will be who is the person who applies this write operation first will be released. So you can have to operate one more select operation, something like this. There it is. Select operation could be possible. Everything is okay. But this particular person is still in deadlock mode only. Then how he will be? So if you operate a commit here, obviously it could be released. It could be released. One row has been created. In this way, read conflict will be resolved. So read conflict will be gets resolved, while opponent user must unlock the share lock and unlock statement. What is the meaning of unlock? So meaning of unlock is operate commit on the particular user. Otherwise, or second operation will be opponent could also apply any one of the write operations on the same resource. Either insert, update, or delete operations will be gets operated. Obviously the lock will be gets released here. So showing some message. So deadlock has detected while so waiting for the resource. Okay. So here it is, commit is over, and here also let me operate commit again. Now, oh, the time is gets over. So I hope that you do understand what is how deadlock will be gets detected. I hope that you do understand. So this is the way to get the deadlock kind of issue here. So here, let me copy everything. From here to the standard one. We have looking forward this particular here. Okay. So when we have to operate either insert, update, or delete, yes, you can get this. Okay. So therefore, the time is approaching. Only 4 minutes are available with us. So it is not possible to explain 4 minutes for so these things. The read-write conflict cannot be explained, or at least each and everything will be taken approximately 9 to 10 minutes here to explain this one, because I need to operate many conditions. Tomorrow, I shall continue with the read-write. So write-read and then write-write. Let me explain these three conflicts by tomorrow. Okay. So don't go away. Let me take your attendance for a while. Don't go away. సో వన్ థింగ్, ఒక్కసారి మీరు ఎవరైనా మాట్లాడాలంటే మాట్లాడచ్చు నాతోటి. సో ఇక్కడ మీరు అబ్జర్వ్ చేస్తే మీ సీనియర్స్, సూపర్ సీనియర్స్, 4th ఇయర్స్, 3rd ఇయర్స్ ఎగ్జామినేషన్ ఫీజులు పే చేసుకుంటున్నారు.